All right, so the sum of the digits of a two-digit counting number was 7. So a two-digit counting number is like 27, 36, 52, okay? So some sort of two-digit number. And if we have a two-digit number, then we have a units place and we have a tens place. So the sum of just the digits is 7. So that means that it could be 1 and 6, 2 and 5, or 3 and 4, right? It's the sum of 7. So the first equation you're going to write for the sum of the digits is 7 is t plus u equals 7. All right, so whatever's in the tens spot plus whatever's in the units spot is equal to 7. Okay, then we need to know the value, the actual value of the numbers. So value of original number. So if you have a 3 in the tens spot, its value is actually 30. And if you have a 2, its value is actually 20, right, in the tens spot. So for the original number, it's always going to be 10t plus u. So 10 times whatever's in the tens place, the digit, plus the u. Okay? And then we have the reverse. So the reverse value. So if I were to switch the digits and flip them, well, now it would be 10u plus t if I flip the digits so it goes the other way. Okay, it's always going to be that. So the value of the original is always 10t plus u, and the reverse is always 10u plus t. Okay? So now it says when the digits were reversed, so my reversed value, the new number was 27 less than the original number. So the new number, that's the reversed number. So that's when you have 10u plus t, the reversed number, was 27 less than the original number. So the original number is this guy right here. So 10t plus u. And it's 27 less than the original number. So for the first part, you're just doing t plus u equals whatever they give you. And then for the second part, you're actually doing the value. So you're always going to have original and reverse. Okay? So now I'm going to substitute in. So we're going to solve for either one. It doesn't matter. So let's say I solve for t. So I'm going to subtract u from both sides. So t is equal to 7 minus u. And I'm going to take this 7 minus u and substitute it in wherever I see t. So that would be here and here. So I have 10u plus, and I'm going to replace the t with what t equals up here, 7 minus u. And on this side we have 10. This time I have to do parentheses when I plug in the t, 7 minus u, and then plus u minus 27. Now I have all u's, so I can just solve it. So I'm going to combine like terms here. I have 10u minus 1u, so that's 9u plus 7. And I'm going to distribute the 10, so this would be 70, and this would be minus 10u. And I'm going to combine like terms now on the right-hand side. So I have a negative 10u and a plus 1u, so that's negative 9u. And I have 70 minus 27, so 43. Let's get all of our u's on one side, so I'm going to add 9u over to this side, so we have 18u. And I'm going to subtract 7 over to this side, so we get 36. Divide both sides by 18, and the units digit is 2. Okay? Go back up to your original equation up here. If the units digit is 2, then what is the tens digit? 5. So the tens digit is 5. So that means my number is 52. Tens digit's 5, units digit is 2. The sum of the digits adds to 7. Okay? And if we wanted to check our answer, we could, right? The reversed value, what would the reversed value be? 25. So we could say 25 is equal to 57 minus 20, or wait, sorry, 52 minus 27, okay? Let's try this one.
That's
I know, it's not great.
we can guess that.
You probably could. Yeah, that's what happened in first period with one student. All right, let's try this. So the sum of the digits of a 2-digit counting number was 9. All right, so the units plus the tens is equal to 9. So that's just sum of the digits, right? Okay, and then we always do the same thing for the original number value and the reverse number value, right? So for the, let's just put original value. I don't want to write that out. For the original value, what is it going to be? 10t plus u. So we always multiply 10 times the tens for the original value. And then the reverse value is always going to be what? 10u plus t. Good. Okay, so now let's read and write an equation. When the digits were reversed, the new number was 45 less than the original number. So when the digits were reversed, the new number, that would be the reverse number. This is the new number, 10u plus t, there's my new number, was, that's the equal sign, 45 less than always comes after, so we can put that out here, the original number, which would be 10t plus u. Then we just do substitution with the original one. Do you want to solve for u or t? Doesn't matter. We'll solve for t this time. So t is equal to 9 minus u. So I'm going to replace the t here. Oh, maybe I did do t last time too. I don't know. Whatever. Okay, doesn't matter. So 10u plus, plug in t, so that's 9 minus u. And plug in t, 9 minus u, plus u minus 45. Combine like terms, so 10u minus 1u is 9u. Distribute over here, this would be 90 minus 10u plus u minus 45. And let's combine like terms over here. Negative 10u plus 1u is negative 9u. 90 minus 45 is 45. Add 9u over to the other side, and we get 18u. Subtract 9, and we get 36 again. Weird. Divide by 18, and the units digit is 2.
7.
Yeah, so if I go back up here, the tens digit is 7, so we get 72. Okay? By the way, if you get a decimal, did you mess up? Yes. If you get a negative, did you mess up? Yes. If you get a number that's not between 0 and 9, you messed up, right?
Really?
Because it has to be a digit. It has to be like a 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay?